We have Boris Sheremich. Boris, you're free to
Thank
speak.
you. Yeah, thanks a lot. So I actually had a question for Dawn. Dawn, have you thought of using, I mean, you do move your load on the bridge and then you record those maximum moments or strains and so on. Have you thought of using influence lines and influence surfaces, using Batty's and Castellanos theorems to actually come up with those locations that will give you absolute maximums of moments? And
Yes, we have done that in the longitudinal direction. So in the transverse direction, we actually had to do a little bit of both manually and also, so actually my student did a separate program just to generate the inference line in the transverse direction. So that we have done quite a bit of that. It's just, it's not that easy to just take the charts from that. And then there are not that many developed for various bridges configurations. But yes, we have been using that inference line. The inference surface is the optimum one, but we had to do a combination with the manual moving and also that result. Yeah. Thank you.
Thank you.
I saw Sachi.
Hi.
Yeah. Mm-hmm.
A question for Khalid. I know, is it Khalid or Salim who's going to answer? Any coordination with Caltrans on Shakecast? It looks like some of the stuff you guys are doing kind of parallels what happens in Shakecast.
We have not talked about that yet, but we are kind of planning to coordinate with the G2F team. And I guess you might be aware that there's a presentation that people from Shakecast will also be listening to. I think we can talk about that after that, maybe more in detail. But in our meetings, internal meetings, we didn't talk about that, but that's a great possibility actually.
Yeah, Shashi, is this Shashi? Hi,
Yeah.
this is Sharon. Just kind of give, touch a little more on that, is that on Shakecast, our current system, we use the HASIS-based fragility on a lot of the fragility analysis when the event happens. Particularly for this BRACE2 project, we are really looking into bridge-specific response on the Hayward Bridge. There will be some coordination between the G2F team, which lead by Cliff, and I'm pretty sure, and your help on some of the damage state assessment and the modeling of the component of bridges. But currently, we haven't had any thoughts into putting it into, have connection with Shakecast right now.
No, got it. Yeah. Another quick question to Farzeen. I know in the damage index you're looking at, I'm going to present something later on. You're looking primarily at ductility, yeah? It seems
is a sophisticated version of ductility. You're correct.
Yeah. So, what about things like, low cycle fatigue? And I mean, if for a near fault earthquake, maybe your predictions are going to be quite reasonable. But if you start to have cyclic degradation and so on, it seems like, you might fall short of predicting what the damage might be by just focusing only on the maximum displacement demand.
First, I agree with you that we need to look into more, let's say, detailed EDPs on the capacity side. But the project that we are doing is focused on a damage index that we have information from test results in Reno, and those test results, again, is in a damage index form. Now, we can build models the way that you or Michael have developed in the past, and try to first train the models to make sure that they can capture the results that happen in the experiment. And then from there, start building more and come up with more, with better fragility curves for those sophisticated EDPs. But at the current step of this project, the focus is only on damage index. The PDCA team has embraced these damage index. They like working with them. That's why we are also focusing on the damage index. But your point is well taken. There is a need to look into detailed EDPs. Now, you can also come from another direction. And that is we develop our analytical models that can do a better job in estimating behavior. That from there, we can do a better job in estimating damage index demand. That is something I need to look into. You're correct.
Thanks.
I saw we have a question from Walter that's directed to Salim. To reach the real-time assessment, how many bridges in California need to be monitored with sensors?
Okay, so I guess there are two questions, right? Maybe I can answer that one first. So actually this project really at this point doesn't focus on a regional scale. So our main objective here is basically to show that we can do this real-time and near real-time assessment using sensors on a particular bridge successfully. And after we show that, the hope is to expand it to other bridges and at some point to move it on a regional level. So that's why that we are not really focusing on that question. As I said, we are mainly focusing on demonstrating that this combination of sensors and simulations work well for decision making about bridge operations right after the earthquake in real time or near real time. So that's the main goal here. And again, the hope is to expand it to other bridges on a regional scale later on.
And there's a second question. How were the soil parameters of bridge foundation collaborated in the optimization process?
So actually that is part of the general optimization process. In one of the slides that Professor Mosallam showed, there were a couple examples of the parameters, and the soil parameters is part of those parameters. And basically we are following a two-stage process to do that. And the first includes a sensitivity analysis, where we identify which parameters have the most effect on the response. So it could be the period or the acceleration time series and all that. So the sensitivity includes identifying the parameters which have reasonable effect. And after that, similar to the bridge parameters, the soil parameters go into the same optimization algorithm to minimize the difference, let's say, between the identified and computed periods. That's what we are currently doing. So in that regard, it is a part of the whole process of optimization.
Thank you, Son. I think I talked to them enough too much that they don't want to talk anymore.
If you want, I can ask a question from Salim. Salim, Khalid showed a slide on calibration of models based on instrumented data. Now, there was an objective function that I didn't understand it well. Can you please explain how do you, what is that objective function, and how do you calibrate and constrain the input or parameters to make sure that you capture the results right?
Sure. Should I show the slides or just explain it?
You can share your screen. Salim.
I have too many presentations open. This one.
Salim, you're a lucky man. We don't have that many presentations, so.
Yeah, general lots of things. Okay, so here, basically, this is this box. You can see my screen, right?
I can see it. I can see it.
This box shows that optimization objective function, and here this is actually the first step. So now you see there are three identified periods, mainly one in longitudinal, one in transverse, and one in torsional modes. And and also there are 3 of these from computation. So what we are trying to do is by changing the parameters of the bridge model, we are trying to minimize the difference between all this. And here we add the weight function, because let's say if we consider torsional may not be important in a case, we can adjust the weight of that to be smaller, but eventually, you know, this is the function to be minimized by changing these parameters. And these are actually mostly examples. There may be others, so we didn't list all of them here. But the key here is these parameters obviously need to be sort of in a realistic range, right? Because otherwise, like if it goes from 0 to infinity, obviously we can match any identified period with any random number. So that's why that, you know, upper and lower bounds is the critical aspect of that. And for now, we are using this mean minus 2 standard deviation and mean plus 2 standard deviation for those bounds. And we are trying to get the standard deviation from realistic coefficient of variation values from, you know, either literature or other sources. So that's the whole, the general idea about this process.
Now, can you also show the model of the bridge that you are calibrating, please?
Oh,
So
actually, that's not.
This is, I think, is good enough.
Yeah.
So it makes sense that you're constraining the model, but one thing that comes to my mind is there are models that are source of your variability, model parameters that are the source of your variability. But there is a higher level of uncertainty, and that is how good is this family of models that were used to represent this bridge. For example, if I ignore putting a shear key in my bridge model, no matter how much I change the parameters of all the other model parameters that I have, I wouldn't be able to capture the true behavior of this bridge. Now, have you guys thought about this?
Actually, that's a great point. And to address that, what we are trying to do is we are trying to use, you know, all the state-of-the-art modeling techniques to our knowledge to model these components. So that's why we are trying to, you know, model all the important parameters of the bridge, you know, including columns and the superstructure and the abutments, in-span hinges, and so on. So once all of them are there and we are confident with that basic modeling and making sure we are not missing anything important, then we can have more confidence on the optimization process. So we have that in mind, and we are not, like, our objective is not to miss any important modeling aspect from the start in the modeling process. So actually that kind of goes here in this slide. You know, this model development includes that. So here in this model completion, all of the important components, let's say, of the global model, we are trying to make sure they're all there.
Right. Thank you so much, Salim.
You're welcome.
Boris, go on ahead.
Yes, I just have a question. So that's precisely the point. You said that you want to make sure that you're not missing any important components of the model. That's exactly the epistemic uncertainty you're trying to address. And how do you know what are the important components of the model? I'm not expecting any answer, but this is the main point. This is the main question, and so this is really, really important. And
so we are, as I said, we are mostly relying on the, you know, the state-of-the-art modeling based on literature, and to some extent Caltrans STC, but beyond that, obviously literature, and we are not trying to miss any recent modeling, you know, studies that people are doing. So,
but you're the first one to do these models, and so you can't find these models in literature. This is the main point. You're discovering some new knowledge, and you can't.
Yes, sure. That's a great point. But that, like, we so actually coming back to that, I can share my slides again. those other 4 bridges that we are using actually become really helpful in that process, because some of those bridges, let me share the screen.
If I may just say, you should be able to develop models that have all the components, and then you can see which components make a difference and which components do not make a difference.
Yeah, so that's what we're trying to do. But in terms of like which component to model, as I said, we are using state-of-the-art, modeling papers or publications, and also some of these 4 bridges that we are not using in real time. Some of these, let's say the El Centro bridge, it has been studied sort of extensively. And one of the students is particularly working on that, and he found some of the parameters of, let's say, the abutment springs from some previous literature and so on. So in that regard, we have some models of some of the bridges, and also we have enough data from these bridges, which we can basically calibrate our models. So yeah, I agree with the process, and that's what we are trying to do. We basically model everything necessary for the bridge, and we are quantifying the uncertainty using the sensor data. So that's the approach in my mind that we are following.
Good. Thank you very much. Thank you.
Any more questions or comments for the panelists? Right. So I think that's it. So thanks to everyone for presenting your presentation, and this concludes the end of this session on Peer Bridge program.